back to my next video. In the previous videos, we have discussed about the acid bases, their concept, classification, preparation, physical and chemical properties of acid and bases. So, now we will start a new topic that is related to acid and base. Good morning to all. This is the next video related to acid and bases, and today's topic is pH of a solution. Clear? So what is the need of this pH of a solution? pH of a solution is required to determine the strength of acid and bases, because already we have studied that some acids are strong, some are weak. Similarly, some bases are strong bases, some are weak bases. And in somewhere we need the exact value of the concentration of the acid and bases. So for that we will start a new topic that is related to acid and bases, that is pH of a solution. So the pH of a solution is first given by the biochemist known as Sorensen, and it is first discovered in 1909. So pH concept is first given by a biochemist known as Sorensen, and it is given in 1909. So now we will discuss what is actually pH. What do you mean by pH? So pH means, if we will go to the definition part, the definition is minus log of, it is the minus log of hydrogen ion concentration, in terms of moles per liter. So when we will talk the definition of pH scale, it means it is the minus log of hydrogen ion concentration in terms of moles per liter. Okay, so here so many new terms you can see: log, concentration, moles per liter. So this we will explain later on. Previously we will see what is actually pH. What is the full form of pH? What do you mean by pH? pH means potenge. P for potenge. Potenge, which basically means power. Clear? So P stands for potenge, which is known as power. Clear? And what is H? H is hydrogen. So we can also say it power of hydrogen. pH means power of hydrogen. So remember, the pH is power of hydrogen. It determines the power of hydrogen. Means what will be the power? Okay, in terms of log, means log base 10. Here we will include another term, base 10 of hydrogen ion concentration in terms of moles per liter, that is called as pH, or that is known as power of hydrogen. So remember, pH is always inversely proportional to hydrogen ion concentration. The pH is always inversely proportional to concentration of hydrogen. Here I have used the word concentration of hydrogen ion concentration in terms of mole per liter. So concentration is represented by this square bracket. Concentration is represented in square bracket, and for that the unit we are using, that is moles per liter. We are using this equation unit, that is moles per liter, means 1 liter. In 1 liter of solution, how much moles of H plus ion concentration is there? So already in class 9 you have studied about mole. What is mole? Mole is 1 mole equals to 6.022 into 10 to the power 23 number of particles. 1 mole equals to 6.022 into 10 to the power 23 number of particles, that is mole. So what is pH scale? pH means potency of hydrogen. Potency of hydrogen means, because this is a Latin word potency, so simply we can say power of hydrogen. So power of hydrogen means hydrogen ion is there. So pH is related to hydrogen ion concentration. Hydrogen ion concentration means here it is represented in square bracket. Concentration is generally represented in square bracket. So H plus ion concentration in terms of, the unit is moles per liter, means number of moles of hydrogen ion in per liter of solution. And the concept is that pH is inversely proportional to H plus ion concentration. pH is inversely proportional to H plus ion concentration. So if we will go now, if we will see the definition, it is the minus log base 10 of hydrogen ion concentration in terms of moles per liter. So what we can write, that pH is equals to minus log of H plus ion concentration, minus log of H plus ion concentration. So this is the concentration of hydrogen ion. So now here one mathematical operator I have used, that is log. For example, if we are writing 45 equals to half, whether it is possible 45 is equals to half? No, it is not possible. When it is possible, when we are writing sine 45 degree equals to half. Sine 45 degree equals to half. Clear? Is equals to half. So similarly, whenever we are writing this is the mathematical operator. Similarly here the mathematical operator we are using, that is minus log, and here also I have mentioned base 10. So here the base will be 10. Base will be 10. Clear? So hydrogen ion concentration, here this minus log 10 is the mathematical operator. Clear? Clear now? So we can say that whenever we are writing the pH equals to minus log 10 of H plus ion, that will gives you the pH of the solution. So this is the mathematical equation of pH. And you will study log. What is log in higher classes? What about log? But I will tell you how to calculate pH here. Mathematically how to calculate pH. For example, if I will tell that 10 to the power minus 7, its pH is 7. If the concentration, hydrogen ion concentration is equals to 10 to the power minus 7. Hydrogen ion concentration is equals to 10 to the power minus 7, then the pH will be equals to 7. How can we find out that when the hydrogen ion concentration is 10 to the power minus 7, pH equals to 7? Let's find out. How we can find out? Put in the formula. Here the hydrogen ion concentration is 10 to the power minus 7. So we can write minus log 10 of 10 to the power minus 7. 10 to the power minus 7. Okay. So remember, when there is log 10 to the power x, if it is like this, at that time we can write it as x log 10. Log 10 means whatever will be its power, that will be its coefficient. Clear? So log 10 to the power x can be written as x log 10, means its power will become its coefficient. So here the power is minus 7. So minus 7 minus, and this minus 7 will become plus 7. So remaining is log 10, and remaining 10, log base 10 is there. So log 10 is there. Remember, log 10 equals to 1. Log 10 is equals to 1. So that's why we can write 7 into 1 that is 7. That is 7. Clear? So in this way we can calculate the pH of a solution and it justifies the definition of the pH. I have told you what is the definition of pH. It is the minus log base 10 of hydrogen ion concentration in terms of moles per liter. In terms of moles per liter. So here this is the formula, pH equals to minus log 10 base H plus ion concentration. Here I have mentioned the H plus ion concentration is 10 to the power minus 7. That's why we have put the value H plus ion concentration as 10 to the power minus 7. Minus 7. So what is the formula? That if log 10 to the power x is there, x is the power, then x will become the coefficient. So here 7 has become the coefficient because minus and minus become plus. So it is the 7 coefficient. Now remaining is 10 log 10. Log 10 value is equals to 1. Log 10 value is equals to 1. For example, sin 90 degree is 1. Similarly, log 10 is 1. So we have put the value log 10 as 1. So 7 into 1, that is 7. So that's why this. So here you can see the hydrogen ion concentration is 10 to the power minus 7. So its pH is 7. Means whatever the hydrogen ion concentration, its power, whatever its power, that is equals to pH. That's why the pH is called as power of hydrogen. That's why the pH is called as power of hydrogen, because whatever the concentration power is there, concentration of what? Concentration of H plus ion concentration, its power is 7 minus 7, so its pH is 7. That's why the pH meaning is power of hydrogen or potential of hydrogen. Potential of hydrogen. Clear? So this is the definition and the mathematical equation of pH. Now we will see that always by calculating it is not possible. How we can experimentally find out the pH of a solution? How can we experimentally find out the pH of a solution? And for that there is pH meter. pH meter. So pH range starts from 0. pH range starts from 0 and ends at 14. Ends at 14. So the pH range, this pH scale is starts from 0 and ends at 14. So the pH scale is in between 0 to 14. pH scale is in between 0 to 14. So as already I have told you, pH is inversely proportional to hydrogen ion concentration. Hydrogen ion concentration. It means when the hydrogen ion concentration is more, the pH is less. Hydrogen ion concentration is more, it means lower pH. Lower pH. Whenever the hydrogen ion concentration is more, lower pH. Lower pH means acidic solution. Acidic solution. Lower pH means acidic solution. And now when the hydrogen ion concentration is low, it means the pH value is more, because these are inversely proportional. So when hydrogen ion concentration is less, greater pH value, it means it is basic solution. Basic solution. It means it is basic solution. Clear? So we can say that pH is inversely proportional to hydrogen ion concentration. pH is inversely proportional to hydrogen ion concentration. So when it is inversely proportional, it means if the hydrogen concentration is more, pH is low, lower pH. If the hydrogen ion concentration is less, it having higher pH. It having higher pH. Clear? So greater H plus ion, lower pH value, acidic solution. If lower H plus ion, greater pH, basic solution. So that's why 0 to 7 is acidic pH, not less than 7. Okay, acidic pH. And after 7 up to 14, it is basic solution. It is basic pH. Below 7 is acidic pH, and above 7 is basic pH, and the 7 is the midpoint between 0 to 14, and that is the neutral pH. That is the neutral pH. Clear? So smaller the pH value, more acidic is the solution. Smaller the pH value, more acidic is the pH solution. More acidic is the solution. If greater the pH value, greater the basic solution. Greater the basic solution means with the increase of pH number, the acidic character decreases and the basic character increases. The acidic character decreases and the basic character increases. So less than 7 is the acidic pH, greater than 7 is the basic pH. And exactly 7, which is the midpoint of the 0 and 14, is known as the neutral pH. Now next is the, when I have told you smaller the pH value, greater will be the hydrogen ion concentration. It means more acidic. Greater the H plus ion, greater will be the acidic character. So 0 to 3.5 is the strong acid. 0 to 3.5. Okay, approximately 3.5. When 0 to 3.5, it is the strong acids. Strong acids are having pH in between 0 to 3.5. Strong acids having pH in between 0 to 3.5. Clear? Similarly, from 3.5 to less than 7, or we can say 6.9. 6.9 is the weak acid. pH have starting from 3.5 to 6.9 is the weak acid. Similarly, it starts from 7.1 to 10.5 is weak bases. And above 10.5 up to 14, it is the strong basis. Clear? So when it is 0 to 2, the pH, because pH can be indicated also by changing color, because pH solution is known as universal indicator. pH solution is known as universal indicator. For why? Because litmus, turmeric, methyl orange, phenolphthalein, if this we are considering, those can only distinguish between acid and bases. That cannot tell the exact strength of the acid or bases. It cannot tell whether it is a strong acid or weak acid, strong base or weak base. But pH can give the account of all these things. It can tell the exact strength. It can tell whether it is strong or weak. It can say it is acidic or basic or neutral. Everything can be considered or can be determined by the pH solution, and that's why the pH solution is called as universal indicator. That's why the pH solution is called as universal indicator. So remember, when 0 to 2, it giving red color. Give the red color. Then 2 to 4, it gives pink color. Means by observing the color, we can determine that what will be the pH of the solution. From the change in color, we can approximately determine what is the pH of the solution. So 0 to 2 red, 2 to 4 means above 2, less than 4 it is pink, then above 4 less than 7 is yellow, at 7 it will exactly give green color, then 7 to 9 blue, 9 to 11 indigo, and greater than 11 it is violet color. Greater than 11 it gives the violet color. Clear? So in this way, by changing in the color of the pH paper or the pH solution, we can find out the exact strength of acid. We can distinguish between strong and weak acid, strong and weak base. We can, as well as we can distinguish between acidic, neutral and basic solution. Acidic, neutral or basic solution. That's why the pH solution is called as universal indicator. That's why pH solution is called as universal indicator. Clear to all? So what is pH? I have already told you, pH is the minus log of base 10 of hydrogen ion concentration in terms of moles per liter. Mathematically I have shown you pH is equals to minus log of H plus ion concentration. Since when we calculate this minus log of H plus ion concentration, whatever will be the power of 10, that is the pH of the solution. That's why pH, full form of pH is power of hydrogen. That's why the full form of pH is power of hydrogen, or in Latin it is called as potency of hydrogen. Experimentally we can find out by looking the change in the color of the pH solution. If the color changes, we can say the strength of the acid. We can distinguish between acid and strong, a strong and weak acid, strong and weak base. Similarly, we can also distinguish between acidic, neutral and the basic solution. Okay, so now we will discuss about the importance of pH. Importance of pH. What is the importance of pH? Importance of pH. So what is the importance of pH? Okay, so let's start from the what is the importance of pH in our everyday life. First example I want to give you. Then in our stomach we possess mainly HCl acid. In our stomach there is HCl acid. HCl. Okay, HCl acid. So this acid makes the stomach acidic for digestion, for killing the bacteria, and also to produce some of the enzymes. Those enzyme can produce only at acidic pH. So this HCl is required for digestion of food. Okay, so this is the first importance of the pH. Means this acidic pH is required for the digestion of food. Acidic pH is required for the digestion of food. Clear? So also this acidic pH is required for killing the bacteria in the stomach, for activate the production of some of the enzymes which is required for our body, that is required. So this acidic pH is required for the production of those enzymes. But suppose if that acidity level, means that pH level will decreases or increases. pH level decreases means it becomes more acidic. When the pH level decreases, at that time what happened? The pH level decreases means it leads to more acidic condition. So when more acidic condition will be there, then it is called as hyperacidity. So when there will be hyperacidity, we feel irritation in our stomach. Or stomach pain. We are feeling stomach pain, and excessive secretion of acid, hyperacidity, prolonged hyperacidity leads to peptic ulcer. So that is a deadly disease. Okay, the only preventive measure is the operation. So prolonged hyperacidity leads to peptic ulcer. And why it arises? Due to excessive secretion of HCl, means the disturbance of pH. So if this pH of the stomach disturb, means hypersecretion of HCl. Hypersecretion of HCl leads to hyperacidity. Prolonged hyperacidity leads to peptic ulcer, and that is a deadly disease which can be only preventive measure is the prevention is the operation. That's why to avoid this peptic ulcer we are using the antacid. Okay, and in antacid mainly we are using milk of magnesia. That is nothing but the magnesium hydroxide. Just the magnesium hydroxide. Clear? So magnesium hydroxide is used to neutralize the excessive secretion of acid, that is milk of magnesia, which neutralize the effect of acid, and we feel comfortable when we are suffering from hyperacidity. we are suffering from hyperacidity. So this is the first importance. Second is the generally we are sprinkling in the soil lime. We are sprinkling the lime in the soil. In the soil we are giving lime. Okay, we are giving the lime in the soil. Okay, so what is the use of this lime in the soil? Soil generally when they are having acidic pH, and we know that lime, calcium oxide, okay, calcium lime, it is basic in nature. So when we are spreading this bases lime over the soil, it neutralizes its acidic nature. And that is better for cultivation. That is the suitable condition for cultivation. That's why we are sprinkling lime over the soil. To neutralize the acidic pH of the soil, we are using this lime, so that the soil will neutralize and it will be beneficial for the cultivation. Third importance is the in case of ant bite. Okay, when ant bite, we are feeling irritation, means we are feeling a burning sensation. When there is ant bite, there is a burning sensation. Why there is burning sensation? Because the ant bite, means the ant sting, possesses formic acid. So when ant bite, it releases formic acid. So when the formic acid is released over the skin, we are feeling irritated, or we are feeling a burning sensation. And this is a defensive mechanism of the plants and animal. Of plants and animal. So what is the defensive mechanism? It releases acid to protect themselves. They are bite, and that is the defensive mechanism of the animals. Similarly in plant, nectar plant is there, its sting possesses the acid that leads to irritation. So when the ant bite, you feel burning sensation. Why? Because the ant bite releases the formic acid, and formic acid gives a burning sensation. That's why immediately we are applying the baking powder or the sodium hydrogen carbonate. We are applying the baking powder or the sodium bicarbonate or sodium hydrogen carbonate to neutralize the effect of formic acid. Which gives comfort from the burning sensation. So this is the importance of pH. pH is very essential. For example, in our blood, the pH of the blood is 7.4. So if the pH reduces to 7.2 or it increases to 7.6, then it leads to death. That's why blood resists the change of its pH. And that is called as, that's why blood is called as buffer solution. Blood is called as buffer solution. So what is the role of buffer solution? Resist the change of pH. And that's why the blood cannot be artificially prepared. Why? Because the artificial blood cannot resist the change of pH, and if the change of pH takes place, then it leads to death. That's why we cannot make artificial blood, because blood have a unique property that it resists the change of pH, and the substance which resists the change of pH is known as buffer solution. This is the importance of pH. In our everyday life. And by pH we can distinguish between acid bases, we can distinguish between strength of the acid and bases, we can distinguish between acid, bases and the neutral solution. We can also tell the actual strength of the acid and bases by using pH. Thank you and have a nice day.